Welcome to the Access Lunchtime JSON After Party. Neil Sargent shows us how to not only get information from the web using JSON, but also how to post it using Microsoft Access. Go, Neil.
Yeah.
Okay.
I'm
So this is very much a real-world example. This is a code. I released a version of this commercially today. It is commercial code, but I've been careful to make sure there's nothing sensitive in here. And although we're using a commercial product on the other end of the API, I noticed that their help documentation was on the public internet. It wasn't members only. So I'm quite happy to show you some of the detail about how we take our tables from Access, turn them into JSON dictionaries, and post them up to the API, which it then receives at the other end and puts into its own SQL tables. We've seen a lot of getting information, and I think someone said in the last presentation, it'd be nice to see some putting of information because this is what it is. Now, just to show you the application that we're dealing with here, this is very much a cut down version of the data structures that we're using. We've got a company which does electrical testing. They do testing for customers to meet their compliance for health and safety. They're electricians, they go in, they do testing, they send them a bill, and what my system does is all the administration for the customers. It does the invoicing, it does the timesheets for the engineers, it does their wages. But what it doesn't do is it doesn't do the scheduling. The scheduling, they use a third-party application, which is called FieldMotion. It's a web app application. And what that does, it allows you to send your employees to appointments with customers to fill in a form with some data about that customer, which it will then bring back to you. It does it very well. The great thing about it is it does it on mobile apps, so they can go in there and they can use their smartphones to actually record data and run their appointments. And rather than have to do all that in Access, we've used a third-party system to do our scheduling, but most of the other administration of the business is done by this 20-year-old Access database that I've been working on for many years. So we've got contracts with people who have customers who have multiple sites. So you've got big companies with multiple sites. Each site we have to visit, we do a job. So we're going to do a job for them and to do some testing, some compliance testing. That job consists of a number of tests. We might test their portable appliances, their PATs. We might test their mains distribution board. We might test their fixed appliances like their air dryers in the bathrooms or their fire alarms. So we do a number of tests, and we do that on a schedule. We go every 6 months or every year according to what's required for compliance. So we've got our engineers, and we send them on engineer visits to perform jobs of multiple tests. It's fairly complicated because you've got multiple sites per customer, you've got multiple tests and multiple visits per job. So that all makes it quite a complicated application. Now for the scheduling, we've got these tables over here, which are, they've got the FM prefix. These are tables which I've created in our database to store the data which is used on the API applications to do their appointments. So they've got a number of appointments which they schedule. I actually tell them from my site, I give them the customer information for the appointment, so they send the engineers, which are our engineers also users on their system, so their users are talking about our sites as the customers. They're talking about going to do our jobs. They do their testing and they fill in the data that they've done in terms of what they've tested on the appointment systems forms, and it actually automatically fills in their timesheets, which I also bring back and do their wages from. So the interface between the two is between these Access tables, which I'm using to store the data from the other system, and these Access tables that I'm using to drive the business. So the API has got to send information up about customers. It's got to send information up about engineers and jobs, and it's got to fetch down information about appointments when they're scheduled for, which it needs to update and tell our system when the engineer is going to be there. It needs to read the data that they collect while they do their visit and store that in our system. And it needs to also fill in their timesheets from the time that they spent on site. So we know where the engineers were, what they spent their time on, and who to charge the customers to. So it's a complicated beastie, but what it means is we're posting records from our system up to their system, and we're reading records back from their system into our system. And that's what I want to show you on the API. Okay, so let's go into the actual code. You know, we said when you've got one of these APIs, then there's a documentation that tells you everything you wanted to know about that API and how to do it. Well, here's the Field Motion API documentation. And in the getting started, what they do is they say, what you need to do is do an API request. So this is an HTTP. And what we do is we post. So this is HTTP post operation rather than the normal get operation. With a get operation, you say, get this data with these parameters, and it returns the data to you. With a post operation, what we do is we say, here is some information, here are some parameters about that data, and here is the data itself, and we're posting it up to their system. So we're actually posting records to their system using this. And as I said, Leo, just previously, in this situation, we actually have to post requests to get data. So it's a bit different there. If we get data, we post the parameters as JSON as to describing the data. So we don't use a get, we use a post for both getting and sending data to the system. And what they do is they say, basically, create a JSON set of parameters, tack your API string that shows who you are on it and that you've paid for your subscription, and post it up using API. So that's all straightforward. And so what I've done, and they give an example here of how to post up their data, and they've called it FM API. And funny enough, what I've done is I've taken their example function called FM API, which they've given an example in PHP, and I've done it in VBA along pretty similar ways. So let's have a quick look at that function. This function basically says, take a function, and from that, what we mean by a function is one of these functions to go and get data, send data, a list of functions that they give us on the API. Here are the parameters telling us the parameters for that function. So if it's a get function, this is the name of the appointment that you want me to get, the ID of the appointment, or this is the name of the customer we want you to list. Or if it's post function, and this is the name of the job that we're telling you about that you've got to set an appointment for. And then the third parameter is the data that you're actually posting up. So this is the actual information about the job. This is the parameters about the job, and this is the data about the job. So rather than just the two variables, we've got three variables, one which is for when we're sending data up. And as you can see, these are both objects, and we're handling those as either dictionaries or collections, and we're converting them into JSON to send them up the API. So what we've got to do is we've got to actually get our database records in here, fill in the parameters describing which they are. So if, for example, the job number would be the key of the record we're sending. So it's called job number 12345. And then we'd create a dictionary entry, which has got fields for each of the fields that we've got in our job table. And in fact, this job comprises of a number of tests. So we're going to send you up on job 12345. We're going to get you to test the portable appliances and the fire alarms, and so we might have 3 tests. Go do the microwaves, go do the kettles or the portable appliances, and go do the fire alarms. So what we need then is in there we have to send a JSON array of tests that we want to do for that job. So this, we're going to see here how we're embedding subtable records as further objects embedded inside our job dictionary, which we're going to send up. So the basic function basically starts off by saying, taking the dictionary, if I've provided a dictionary, what it does is it clones it. It clones it so it can add on the API stuff that they said. If you remember, they said in the API to get started, what we have to do is we have to dictionary of the parameters, yeah, add to that our API key, add to that the date and time, an MD5 hash so we can check that it got through properly, and then post it up. So what we're doing is we're cloning our parameters and just adding these extra fields that they're asking us to put in, which are the current timestamp, the MD5, our ID, and in there is actually our sort of embedded secret code that tells us to actually who we are, so it identifies us. We then create a new connection using the web client option in the JSON web, and we set up the request. So the request is an HTTP post rather than the normal GET. It's going up form URL included, which basically means it's going up as %included, %hash encoded URL. The response is going to come back in JSON. The function that we want to run is the actual resource, if you like. That's the subdomain that you use to actually get the function out of the API. We saw this in Maria's original post. And then the body is the actual post that we've just created as dictionary. So what we're doing is we've actually sending up the body. And what happens is that gets converted, because we've said it's JSON, inside Tim Hall's VBA web code. It will take our dictionary, it will convert it into JSON using the parse JSON function, and it will send that JSON up as part of the HTTP post. So all we've got to do is provide the VBA dictionary that contains the data, the body of what we're sending up. That's either our parameters or the actual information about the data that we're sending up. So then we call it, we execute it, we get a response, and then the response either comes back as, yeah, everything's okay, or something went wrong with the actual request, and we'd handle that as an error and send it back to our application saying something didn't happen. We asked the API to do something, it came back with this error code. So that's the basic function, and that function is the API function. That's very similar to Maria's function that she originally presented a couple of presentations ago, to actually post it up using the VBA web code to the gen data. So let's have a little look at an example of getting that data down. We'll do this very quickly because this is the bit we've seen before. So basically there's an appointment get function, and it says in the API that what you're going to get back is this JSON string. So rather than a description of the JSON string, they just give an example. And what I found working with this API was, unfortunately, the example isn't all inclusive, because sometimes fields that they haven't mentioned in their example suddenly appear and so on. Also, you'll notice that here that everything is a string. There's one of those nulls that Colin was asking about. There's a null going up. You see, it's not a string saying null. It is actually the JSON definition of a null. So that is actually the location it's saying is a null. And from our point of view, that would be a null in a variant. But you'll also notice that here we've got a JSON string with this curly quotes. Can you see it's got quotes around it? So in fact, it's not part of the JSON. It's just a string value that happens to have further JSON in it. And that was the thing which caused me the problem, where I had to actually say, if you see one of these strings, treat it as JSON and go in there to force my interpreter to interpret these embedded strings of JSON as JSON. Because normally what would happen is those quotes wouldn't be there, and the VBA web would automatically recurse into it. It'd say, I've got an object, it's got these elements, ID, form, and then it says, oh, it's got this form values, which is a dictionary of these things. But because of the quotes, it says, oh, it's got form values, it's a string. So it just treats it as a string, it doesn't come back as an object. Now that's just, as I say, peculiar, I think, to this API and the way they worked. Okay, so that's telling you what's coming back. So we read it, we just call read API, OData, and it comes back in our OData dictionary. And then what we do is we call appointments get save in the OData, we take the dictionary, and we say, okay, select our appointment. So this is where we're going to put it. We've asked for information about appointments, and we're going to put it in this table here. So it says, get a record set for the appointment. If we don't recognize it, then we're adding a new version. Otherwise, we're editing an existing one. And then for each item in our data dictionary, get the field name, which is the name of the key. And if object exists, that's basically just checking that our record set has got a field of that name. Because, as I said, sometimes they add fields that we don't know, or in terms of forward compatibility, they might add fields to an API. They've got new fields in their database record that we don't know about. So I have to first check that it's a field I recognize. Then if it is, then take that field and read if the value is null and put it in as null. If it's a dictionary, then go save the JSON, or if it's just a normal value, save the value. So you can see here that strings are either being truncated to, if it's text, I'm making sure it doesn't overflow the size of my text field. If it's a memo, then I just read the whole lot. If it's and likewise, they're all coming back as strings, so I just basically make sure that I don't overflow my 255 character limit. I don't care how many strings characters they've got, so long as it doesn't overflow my record. I'll just truncate it if they send them something too long. So here what I've done is I've actually effectively read that data into the appointment table. Now, getting to the more interesting stuff, because we've seen that before, let's have a look at actually posting appointments. Now this is more interesting because here what we're going to do is we're going to wrap up one of our database records or some of our database records here into a JSON dictionary and then send it up the web for it to actually decode and do what I've just done with what it sent me. So first thing we do is open a record set. Now I'm using a query here to go and get a composite of information about the job, the engineer doing the job, what he's got to, when he's got to go and do the job. So I'm using a query called engineer summary, which is basically combining these 5 tables here and sending up the information. So I open my record set, I then go through my record set and do a do loop for each record. So I'm now going through appointments that I want to tell the API system about. So what I've got is here, for each record, what I'm going to do is actually create an appointment. So I create a new dictionary. So this is my appointment dictionary. And then what I'm going to do is, has the dictionary got allocations? So in other words, am I sending one or several engineers to this appointment? So I create a dictionary of engineers, which I'm going to embed in my overall appointment. So I've now got an array of engineers, which I'm going to actually send up within my appointment, saying which engineers are going on the appointment. I go through and I'm filling in the customer ID with the information, form ID, that tells him what type of job it's going to be, what form he's got to fill in at the other end, when the meeting time is, so when I want to schedule the meeting for, some notes going in there. Here I've got the form field, so what I've got to do is create another dictionary. So now I'm going to go through and say, right, these are the values that I'm going to fill in as the fields for you to complete in the form on the appointment. They're going to fill in for me. Now I'm going to create another record set, which is gives me a list of jobs that I want to do. So this is what I'm going to tell you to do: the microwave, the fire extinguisher, and so on. And then once I've finished that, what I've actually ended up with, I won't label it anymore, but we'll then go through and basically say, once we've created our appointment dictionary with its embedded arrays of dictionaries in it, I've got arrays of tests to do, arrays of engineers to send. It's very much like a composite dictionary that we saw before. We then actually post it up. Now I don't just post them up one at a time, and I don't go through and post them all, because say for example, last time I told them about the engineers, I've created 100 100 appointments. If I send 100 appointments up and tell it to do it in one fell swoop, it's going to clog up our systems and their systems. So what I'm doing is I'm actually doing a thing here saying break it down into batches of half a dozen or so appointments and send them up a chunk at a time. So once I've actually done that, I then say, oh, send up a post. And what I've got is I've got a collection of appointments and a collection of new appointments that I want to send up. So what I've created here is an object which is a collection of records, one per appointment, that are either existing appointments I want to update or new appointments that I want to create. And then I call my API function. I call the appropriate function, whether it's either appointments new or appointments save, which are the two functions to save existing appointments if I'm updating, or create new appointments if I'm creating them. And eventually I've worked out what I'm going to send. There it is, FM API. There's the actual function. So the function to actually send it sends up the parameters and the data that I've sent. Now, sorry, what I didn't make clear was what the response it does. In this particular case, what happens is I've created a list of appointments that I'm going to send up the API for it to include in its system. And what it's going to return is it's going to update its database, and it actually then returns the same appointments back as it's interpreted them. Now, what that means is, say, for example, I've created a new appointment. It's going to assign a new appointment number to it, which is going to be its unique key, and then it's going to send it back to me. So I'm going to receive back the appointments I've sent with the unique key that it's allocated on it. So I basically then created in this table, I haven't actually put what I wanted as an appointment into this table. I've sent out the API and it's sent back its appointment in its format, how it's interpreted it, for me to save in my table. And that way I know that now I've got an exact mirror copy of what I've asked it to do. So I know that looks horribly complicated. It's whizzed through someone else's code. But what I wanted to show you was how we actually use the JSON to actually, we use our VBA to turn our database records into a set of dictionaries and collections. We turn that into JSON and send it up. And that's the opposite of what we're doing everywhere else. We've received JSON and interpreted it as database records. And I think it's important to see the posting going on, because there's less of this, certainly much less of this available on the internet. It took me a long time to learn how to do this. So are there any questions on that?
No questions, Neil, from me, but this is just really, really fascinating, and I love that you're going into all this detail.
Okay.
Yeah. I do have one question. I think I know the answer already, but I just want to confirm that I understand correctly. When you're posting back, the API that you're posting to must accept and handle the JSON as a part of an operation to write that to a data store, correct?
Correct. Yeah.
So if you don't have an API that can accept it,
Absolutely. This is because most of the APIs that we've seen examples of, largely for proprietary reasons, are simply providing us with data, like the Google APIs tells about books, the Maps tells us about maps. We've seen a lot of getting data. I wanted to show an example of sending it up for it to store at the far end. And in this case, what I'm doing is I'm sending it up in JSON, it's storing it and returning either an error to say something was wrong with that data you just sent me, or the set of records that it has saved. And that way I'm getting its allocated defaults, I'm getting its primary key and so on and so forth. So I've then got a copy of its data. A bit like when you, in the record set, when you post a record set and then you read back the allocated ID by going to the bookmark for the last added record. You know how we do that to find out what the allocated number was, so we can use it in our as a reference in other tables. very much like that. We're posting up, here's some data I want you to create records with. Send me the records you've created back, and I can then read what defaults you've allocated, how you've interpreted my data, and what keys you've added. Is there any questions on that?
Yeah, I have a question, Neil. And the reason why the API sends back everything is because that's the way it does it. But if you weren't using a third-party API, if you were developing your own thing, then you could send back less, right? Like just a record key and
Oh
just
yeah, and that's an option. That's an option on this. It would just send me back the allocated key as a single JSON value, and that's actually the normal operation. I think in this application, what I'm actually doing is I'm actually maintaining a copy of what's going on the other end so that I can synchronize. And I've actually do this to synchronize this in a background process so that if the API is down, I can carry on adding records on my side. And then when the API comes back, I can post up everything that's changed on my side. And you'll notice that all of these have got last edited.
Yeah, so what do you do in the case where you post some records up and you've edited them, but somebody on the system has also edited them after your system read them? So basically you have two copies of
Oh,
changed
conflict. So
data.
because I'm synchronizing, very simple rules in this system, last one won. In fact, the actual application itself, we don't get much conflicting because the way it works is that we create everything on the database, we post it up, and then we post it up without a date and time. They schedule it on the other system, and we read back what the dates and times have changed to. We don't actually in this system create appointments on the FAR system. We create them all on our system, and that way we don't get so many conflicts. But where we do get conflicts, it's last one who updated wins, basically, because it's a very simple conflict management thing.
I would imagine that where the differences would be the notes. I don't know if your structure keeps track of notes.
To be honest, we try to avoid overlap. For example, what we do is we send up the job notes, but once they're over there, they're not editable. And what comes back are the engineered notes, which are his notes on what he did on the appointment. When they come back to us, they're not editable. So the way we've avoided conflicts is that we've got different notes fields for each of the two systems, so we don't end up clashing.
Okay. Well, thank you. That makes a lot of sense.
Yeah, it works in this application because we're not synchronizing the same data. What we're doing is we're saying, we over here are deciding on the jobs you've got to do. You go over and do them, do what you're told. You can work out when you're going to do them, tell them when you're going to do them. And then once you've done them, send the data you've got back and we'll store the data you've done from it. So it's the flow of data is very much originates here, goes over to there, comes back to here. So because it's a circular flow, there isn't much conflict going on. Yeah.
Excellent job. Thank you, Neil. Thank you, Leo.
Thank you.
Yeah, and thank you, Leo. I was very interested in your alternative one there. It looks great. Bye, everybody.
Bye-bye.
Bye-bye.